Good morning, children. And this unit we are discussing about pressure, force, etc. This unit is explaining about the properties of fluids, and we will start this unit today from problem number 2. Calculate the pressure exerted in a column of water height 0.85 meter, and its density of water is given, and a kerosene of same height, its density is also given. So we are noting down. So there is a formula for pressure H rho G. This is for water. Then H rho Wg. And for kerosene we can write the same formula H rho Kg. Everything is given substituting. We are getting the answer for pressure. Unit is Pascal. Next is atmospheric pressure. So what is atmospheric pressure? So our Earth is all round filled with the gas, and the combination of gas is called as air. And this air is nothing but it is made up of atoms and molecules, and these atoms and molecules are giving the pressure in all the directions. So we are acquiring that pressure. This is called as atmospheric pressure. So gas, atoms and molecules are giving some pressure. So this pressure value is varying from height to height. When we are going high, the pressure value is decreases. This pressure is happening due to the atoms and molecules which is present in the gas and air. This is called as atmospheric pressure. And here, do you know, is given for human lung. His breath well adapted. His the value is compared with sea level 101.3 kilopascal. Okay, it is given here. Then measurement of atmospheric pressure. So here there are some methods how to measure the atmospheric pressure. Okay, it is explained here. And yeah, first the instrument used to measure the atmospheric pressure, which is called as barometer. Okay, the barometer is used to find the atmospheric pressure. A mercury barometer was first designed by the scientist Torricelli from Italy. It is closed at one end, opened at the other end. And now here we'll discuss about mercury barometer, and the diagram is given. See, in this barometer is a narrow tube, glass tube is taken, and one vessel. That vessel is fully filled with the mercury, and inside that narrow tube, having one end is open and next end is closed. First we are filling the mercury inside the tube, then we are inverting that. The open end is immersed into the mercury already filled in the vessel. So inside this tube, so already it is completely filled now. This mercury level will be decreases, and constantly it gives from the top surface of the mercury to 76 centimeter. How much centimeter? 76 centimeter, or in millimeter we can say as 760 millimeter. This value above that, this tube is showing as vacuum. So it's giving this value everywhere almost same, and this is called as mercury barometer, and this level is considered as the constant value for atmospheric pressure. So that we can calculate here. Pressure P is equal to H rho G. This we calculated in last class. So H up to what distance it is increasing? 760 millimeter, that is 76 centimeter. That we are substituting. 1 milli is 10 power minus 3. Then rho is 13,600 kg per meter cube. This is density of mercury, and G is nothing but a gravitation. It is taken as 9.8. We are multiplying all that value. It gives the answer 1.013 into 10 to the power 5 Pascal. And one atmospheric pressure is taken as 1.013 into 10 to the power 5 Pascal, or 1 bar we can write as 1 into 10 to the power 5 Pascal. Then we can write 1 atmospheric pressure is equal to 1.013 bar. And expressing the value in kilopascal, we can write 10 power 3 will be written as what? 1 kilo. Then 10 power 5 can be converted into 10 power 3 into 10 power 2. Then this 1.013 will become 101.3 when we are converting into 10 power 3 into 10 power 2. 10 power 3 will be taken as 1 kilo. then we can write 1.013 kilo Newton. Okay, next problem number 3. This is Mercury Barometer in a physics laboratory. Hope you understood about that Mercury Barometer. Yes, good. The Mercury Barometer in a physics laboratory shows 732 millimeter is vertical, and they're asking to find the atmospheric pressure. There is a formula H rho G. Every values are there. We are multiplying, we are converting into 10 power 5. Then we got 0.976. It is lesser value. Okay. Then gauge pressure and atmospheric pressure. So when we are going deeper into the sea, example the scuba diver which is shown in the figure 3.7, he feels different pressure than on the earth. So it is compared here. The absolute pressure is zero referenced against perfect vacuum, and gauge pressure is zero referenced against atmospheric pressure. Absolute pressure is zero, perfect vacuum. Then the gauge pressure is zero with the atmospheric pressure. Okay, now we are finding the pressure higher atmospheric pressure. Absolute pressure is equal to atmospheric pressure plus gauge pressure. Then the pressure lower than atmospheric pressure is equal to atmospheric pressure minus gauge pressure. So that's why the scuba diver, which is who is going deeper into the sea, is designed the separate dress code, okay, to reduce the pressure. Understood, children? This is called as gauge pressure and absolute pressure. And one, do you know, in petrol bunks the tire pressure, which is shown by PSI. Have you checked that when we are filling air in tire? It's shown by the value PSI. It stands Pascal per inch. This is old system that we are using measuring the pressure. Actually, nowadays we are using what? Pascal, no, but there we are using Pascal per inch. This is the old system we are following to fill the tire. Okay, then Pascal's law, and see the Pascal's law. This is after the scientist's name Pascal. He lived between the year 1623 to 1662. French mathematician and physicist. He gave this law, and he see the picture, figure 3.8. There is a ball-shaped container, and this container made by large number of holes. It is filled by the water, and there is a piston at the top. We are giving the pressure and downward. The pressure we are giving only this area. So where we are giving pressure only this top. Now due to the pressure, this piston is moving down. While moving down, the water will comes out throughout the holes with the equal pressure. So the applied pressure is only one portion that is transmitted equally throughout the liquid. This is called as Pascal's law. So where we are applying the pressure in a liquid, that pressure is transmitted equally throughout the liquid. This is the law is called as Pascal's law. This is the demonstration given. It's a very simple experiment. And based on this Pascal's law, we are having hydraulic press. நம்ம கார் சர்வீஸ்லாம் விட போகிறோன்னா இல்லை பைக் சர்வீஸ் விடுற இடத்துலாம் பார்த்தீங்கன்னா இந்த பைக்கு காரை ரைஸ் பண்ணி க்ளீன் பண்ணுறதுக்கு இந்த மெத்தட் யூஸ் பண்ணுறாங்க. ஓகே, அண்ட் சி திஸ் த பாஸ்கல். With the small force, small pressure, we can raise the car or bike. நிறைய மாஸ் இருக்க பைக்கையும் காரையும் நம்ம ரைஸ் பண்ண முடியும். And see the hydraulic press picture, figure 3.9. There are two openings. One is having the cross section A1 here, and next is cross section, broader cross section A2 here. So this is capital A, and the force we are applying in the first piston, and force here it is acquiring, and say this broader having the force F2, okay, which is maybe car, bike, etc., and we are giving the force F1 in this part. Now this piston is moving down, so pressure P is applied through this liquid. That pressure is traveling, transmitting throughout the liquid. Due to the pressure, this piston A is moving upward. So we are giving the small force at the one end. This small force will raise the huge force in upward direction because of the equal pressure. This is the explanation for hydraulic press. We are comparing the two equations. So pressure applied at the one portion here is F1 by A1. So pressure is what? P is equal to force per area. We studied already. F1 by A1, and here the pressure is in the second portion F2 by A2. Pressure is same, then we can equate these two. So equating these two equations, we can write F2 is equal to F1 into A2 divided by A1. Since the ratio of A2 by A1 is greater than 1, then F2 acts on the larger piston. And also, this hydraulic system work in this way are known as force multipliers. This is the application of Pascal's law. Then problem 4. So this problem 4, all the values are given. We are using the hydraulic press formula. After using that, we are finding the formula for F2. Okay, let's you try yourself, children. And next is 3.5 density. And here this density topic, we are starting with the activity number 5. And this activity 5 says, further we are taking 2 flasks. First one is filled with kerosene and second one is filled with water. These two are taken the same quantity. This kerosene giving the mass 280 gram, water is giving the mass 330 gram. They are asking which flask is heavier. So from this figure itself we can say water filled is heavier because it's showing the mass 330. Why? So there is an explanation. So here say the mass of the flask is 80 gram. So the mass of the flask filled water is 330 and kerosene is 280 gram. So subtracting 80 we are doing the sum. Water 250, water only is 250 and kerosene only we can write 280 minus 80 is 200. Then we are finding the mass per unit volume of water is 250 by 250, then kerosene is 200 divided by 250. Then we are getting the result 0.8 and 1. For water it is 1 g per centimeter cube and for kerosene it is 0.8 gram per centimeter cube. These are the densities of water versus kerosene. So water having the more density. Therefore the density of substance is nothing but mass acting per unit volume is called as density. The SI unit of density is kilogram per meter cubic. And the symbol for density we can write as rho. Okay, that is here it is like look like a P. The symbol for density is taken as rho. Okay, next we are going to give a relative density. So this relative density is nothing but we are going to comparing. So the relative density is nothing but the densities are compared. Two substances we are having. The two substance densities are compared. This is called as relative density. But practically in physics we can take the second substance whatever we are having, but the first one definitely will be a water because this water at 4 degrees Celsius giving the density 1 gram per centimeter cube. So it is easier to compare with any substance. So relative density we can write with the formula the ratio between density of any substance divided by density of water at 4 degrees Celsius. This is called as relative density. And density formula we know mass per unit volume. Okay, then relative density we can write mass of the substance divided by volume of the substance, mass of the water divided by volume of the water. This formula we are getting from this, and density is equal to mass per volume is used here. Then we can write the common formula mass of certain volume of substance to mass of equal volume of water. These two ratios are taken here for relative density. So for relative density நம்ம calculate பண்ணோம்னா water நம்ம compulsory எடுத்துக்கணும். Density of water at 4 degrees Celsius வேல்யூவையும் then ஏதோ density நம்ம எடுத்துக்கிறோமோ அந்த unknown substance density divided by water density நம்ம ratio எடுத்துக்கிட்டோம்னா that is called as relative density. Then measurement of relative density. So how to measure அப்படின்றதை நம்ம பார்க்க போகிறோம். Next is measurement of relative density. To measure the relative density, we are using the device is called as pycnometer. It is also called as density bottle. It consists of ground glass stopper, the fine hole through it. And when we are filling with the water, the stopper is inserted, the excess liquid rises through the hole and runs down outside. நம்ம ஸ்டாப்பரை வச்சு க்ளோஸ் பண்ணும்போது எக்ஸஸ் வாட்டர் வந்து அந்த ஹோல் வழியாக வெளியே போயிடும். So by this way we can maintain the same volume whatever the liquid we are filling. and we can maintain the same temperature, provide the same temperature, we can calculate the ratio between these two. The comparison will be calculated here, and we can calculate the relative density. And if the reference substance is water, then the term specific gravity is also fine. We can find with the help of this method. Next is floating and sinking. What is floating? Floating ன்றது மிதக்கிறது, சிங்கிங்கிறது உள்ள போய் மூழ்கிறது தானே. ஸோ எப்போ மிதப்போம் எப்போ மூழ்குவோம் அப்படின்னா, so the two substance densities are compared. The density of the object, எந்த ஆப்ஜெக்ட் அந்த லிக்விட் இருக்கோ அந்த ஆப்ஜெக்டோட டென்சிட்டி அந்த லிக்விடோட டென்சிட்டி விட ஹையராக இருந்துச்சுன்னா it will be float. If the density of the substance is less than density of the liquid அப்படின்னா it will be float. The density of the substance is greater than the liquid density அப்படின்னா it will be sink into it. ஓகே, ஒரு ஸ்டோன் எடுத்து ஒரு ராக் மாதிரி எடுத்து நம்ம வாட்டரில் வச்சோன்னா இந்த ராக் உள்ள இமர்ஸ் ஆயிரும்ல, உள்ள போய் சிங்க் ஆயிரும். Okay, this is called as floating and sinking. And based on this floating and sinking, there is a example problem number 5. You have a block of mystery material 12 cm long, 11 cm wide and 3.5 cm thick. Its mass is 1155 grams. Asking density and float அப்படின்னு கேட்டிருக்கேன், float or sink ன்னு கேட்டிருக்கேன். Density we can find with the formula mass per volume. We are substituting volume. We are finding length, breadth and thickness. We are multiplying and dividing. The mystery material is denser than water, so it sinks. So what is the density of water? 1 gram per centimeter cube, but we got the answer as 2.5, so it will be sink here. Okay, next is application of principle of flotation. First, here we will discuss about hydrometer, later we will discuss about lactometer. And this is hydrometer, and see the construction of hydrometer is given in figure 3.10. And this is the narrow tube, narrow cylindrical stem. At the bottom of this narrow we having the bulb, that is a lower spherical bulb, and here this lower spherical bulb is partially filled with lead shards like that, and these lead shards are mercury to make this stem as perpendicular in liquid. And in this stem we having the values, the scale is attached. So which liquids relative density has to find, we have to immerse this arrangement into the liquid. For example, we are using milk, means that milk will be taken in this big container. Then அந்த கண்டெய்னருக்குள்ள மில்கில் இந்த ஹைட்ரோமீட்டர் நம்ம ஃப்ளோட் பண்ண வைப்போம். And the top surface of the liquid, that milk, is showing some value on the scale, that is the relative density. So first we will see what is the principle of this hydrometer is flotation. So when it is immersing into the liquid, the equal weight from the liquid is raised here. This is the principle we are using this hydrometer. Using this hydrometer, we can use this as lactometer to check the density of milk, and saccharometer for measuring the density of sugar liquid, and alcoholometer is used to measure the high levels of alcohol in spirits. This is about hydrometer. Just இதை immerse பண்ண வச்சு, liquid immerse பண்ண வச்சுட்டு, ஸோ இந்த ஸ்டெம் என்ன வேல்யூ டாப் சர்ஃபேஸ் ஆஃப் லிக்விடில் காட்டுதோ அதுதான் ஆன்சர். அதுதான் இங்கே ஜூம் பண்ணி கொடுத்துருக்கோம். தட்ஸ் இட். அப்போது அதை வச்சு we can find, we have some standard value of density of some different liquids. அதோடு நம்ம கம்பேர் பண்ணி we can say whether this liquid is having proper density அப்படின்றத we can show that. Okay, this is about hydrometer. And next we will discuss about lactometer. And this lactometer is used to find the purity of milk. ஒரு மில்க் நம்ம யூஸ் பண்ணுற வாங்குகிற மில்க் வந்து பியூரிட்டியாக இருக்குன்றதை மெஷர் பண்ணுறதுக்கு we are using this kind of meter. It's called as lactometer. And this lactometer works on the principle of gravity of milk. இதுவும் ஃபங்க்ஷன் லைக் அ ஹைட்ரோமீட்டர். ஸ்டெம் செல்ஸில் பார்த்தோன்னா சிலிண்ட்ரிக்கல் பல்ப் பாட்டமில் கனெக்ட் ஆகிருக்கும். ஸ்டெம் சிலிண்ட்ரிக்கல் டியூப்பில் பார்த்தோன்னா ஸ்கேல் is mentioned. Thus that scale ranging from 15 to 45. So 15 at top, 45 at the bottom. This test tube is filled with air. இதை நம்ம மில்க் ஒரு பெரிய கண்டெய்னரில் எடுத்துகிட்டு அந்த மில்கில் இதை இம்மர்ஸ் பண்ண வச்சோன்னா it shows the top surface of the milk in container will show some value on this lactometer. That is the range of that. அந்த மில்கோட டென்சிட்டி அவ்வளோன்றதை நம்ம எடுத்துக்கலாம். ஆவரேஜாக பியூர் மில்க்ன்றது பார்த்தீங்கன்னா 32 பாயிண்ட்ஸ் காட்டணும். If it shows 32, it is pure. If it is lesser means we can say it is mixed with water. Okay, some lactometers are inbuilt with the thermometer. Some particular temperature, for example at 60 degree Fahrenheit, we can find out what is the purity of that milk, and also we can find the cream content of the milk also can be calculated using that lactometer. So this lactometer, the device is used to check the purity of the milk. And next we are going to discuss about Biancy. This Biancy is nothing but, இது நம்ம சிம்பிளாக எக்ஸ்பிளைன் பண்ணுறோன்னா ஏரோப்ளேனில் போகும்போது மேலேருந்து கீழே ஜம்ப் பண்ணுறோம் வித் ஹெல்ப் ஆஃப் பேராஷூட். ஸோ பேராஷூட் வச்சு நம்ம ஜம்ப் பண்ணும்போது என்ன ஆகுதுன்னா ஏர் வில் ட்ரை டு புஷ் த பாடி இன் அப்வர்ட் டைரக்ஷன். பட் நம்ம மாஸ் பார்த்தோன்னா இட் இஸ் மூவிங் டுவர்ட்ஸ் அ கிராவிடேஷன். அப்போ என்ன ஆகும்னா மேலே புஷ் பண்ணுற ஏரும் நம்ம கீழே மூவ் ஆகிற மாஸ் ஆஃப் த பாடி டியூ டு த கிராவிடேஷன் இஸ் கால்ட் அஸ் வெயிட். ரெண்டும் பேலன்ஸ் ஆகும்போது we will be ஃப்ளோட் ஆகிற மாதிரி மெதுவாக இறங்குவோம். will be descend our speed. கரெக்டாக மெதுவாக இறங்குவோம், இல்லைன்னா நம்ம ஸ்பீடாக இறங்கிடுவோம் பிகாஸ் ஆஃப் கிராவிடேஷன் alone. அதே மாதிரி when the ball or object is pushed into the water அப்படின்றப்போ that water will try to push the object in upward direction. This is called as buoyancy, or this buoyant force is also called as upward force or upthrust force also we can say. நம்ம வாட்டரில் டைவ் பண்ணும்போதும் இல்லை ஏரில் ஜம்ப் பண்ணும்போதும் திஸ் ஏர் அண்ட் வாட்டர் வில் ட்ரை டு புஷ் அஸ் இன் ஆப்போசிட் டைரக்ஷன். நம்ம எந்த டைரக்ஷன் மூவ் பண்ணுறோமோ அதுக்கு ஆப்போசிட்டில் மூவ் பண்ண ட்ரை பண்ணோம். திஸ் இஸ் கால்ட் அஸ் buoyant force. ஓகே, அண்ட் டு யூ நோ த சால்ட் வாட்டர் ப்ரொவைட்ஸ் மோர் buoyant. அதனால் நம்ம ஈஸியாக சீல பார்த்தோன்னா ஈஸியாகவே நம்ம ஸ்விம் பண்ணலாம் as compared to the fresh water. ஓகே, நெக்ஸ்ட்டு கார்டீசியன் diver. So this buoyant diver is used to show the principle of its work in the principle of buoyancy. இது எதுவும் இல்லை, பென் கேப் வந்து கிளேவோட அட்டாச் ஆகிருக்கும். And this Cartesian diver contains just enough water to float in this liquid. So when we are brushing the bottle, some more water will be added in that. So float ஆகிற வரைக்கும் தான் வாட்டர் நம்ம ஃபில் பண்ணியிருக்கோம். இப்போ எக்ஸ்ட்ரா வாட்டர் நம்ம கொடுத்தோம் அப்படின்றப்போ now it will be automatically sink into the water. So the increasing the average density of diver and this it sinks, it showing the buoyancy, principle of buoyancy. Next is Archimedes principle, and this Archimedes principle is used to find the apparent weight of the object. So see the figure 3.13, and இதுவும் upthrust principle வச்சு தான் ஒர்க் ஆகுது. In first figure, in first oneல பார்த்தீங்கன்னா ஒரு வெயிட் ஹேங்கர் ஸ்ப்ரிங் பேலன்ஸ் நம்ம வச்சுருக்கோம். வாட்டர் வந்து ஒரு ஸ்டோன் மாதிரி டைப் பண்ணியிருக்கோம். W1 is the weight of the object. இப்போது அந்த ஸ்டோனை நம்ம என்ன பண்ணுறோம், வாட்டரில் சிங்க் பண்ண வைக்கிறோம். ஸோ சிங்க் ஆகும்போது some water will be displaced. So W1 is called as the weight of the object. W2 is the water displaced, the amount of water displaced, weight of the water. So in the method Archimedes said in Latin யூரேக்கான்னு ஜம்ப் பண்ணிவிட்டு ரோட்லேயே ஓடினார் while he took a bath. ஓகே, அதுதான் இந்த பிரின்சிபலை நம்ம யூஸ் பண்ணிருக்கோம். and now we can calculate here the upthrust is equal to weight of the fluid displaced. That is equal to apparent weight of the object. We can write here as apparent weight of an object is equal to true weight of the object in air minus upthrust. These two are subtracted. So from that we can find out the apparent weight of an stone. இங்கே ஸ்டோன் கொடுத்துருக்கா. ஸோ ஆர்கிமெடிஸ் பார்த்தோன்னா அவரோட கிங் ஒரு க்ரௌன் வாங்குறாரு, கோல்டு க்ரௌன். அதோட வெயிட்டை மெஷர் பண்ணுறதுக்கு இந்த மெத்தடை யூஸ் பண்ணார். இங்கே நான் ஸ்டோனை வச்சு எக்ஸ்பிளைன் பண்ணியிருக்கேன். ஓகே, திஸ் இஸ் கால்ட் அஸ் ஆர்கிமெடிஸ் பிரின்சிபிள். அண்ட் நெக்ஸ்ட் இஸ் லாஸ் ஆஃப் ஃப்ளோட்டேஷன். ஸோ ஒரு ஆப்ஜெக்ட் வந்து எக்ஸாம்பிள் ஷிப் பார்த்தோன்னா சீல ஃப்ளோட் ஆகிட்டு இருக்கும். அந்த ஃப்ளோட்டிங்க்கு என்னென்ன பிரின்சிபிள்ஸ் தேவைப்படும்னா there are two rules. One is the weight of a floating body is equal in a fluid is equal to weight of the liquid displaced by the body. இந்த ரெண்டும் ஈக்குவலாக இருக்கணும். Then center of gravity of the floating body and center of buoyancy are same vertical line. Okay, இது மாறிச்சுன்னா it won't float. These are the rules for flotation. Okay, then do you know we'll discuss about flotation therapy. So the patient who is floating in water, so already this water is containing Epsom salts rich in magnesium, and when he is floating relaxes, he or she is absorbing this magnesium through their skin, and magnesium helps the body to process insulin, which lowers a person's risk of developing type 2 diabetes. This is called as flotation therapy. So dear children, unit number 3 is over, and this unit's book bag question answer I will send as photocopy through WhatsApp. And as today's homework, you mark lactometer alone, read and write as homework, then send to me. It's photocopy. Thank you, children.